Like AI is really good at learning from the data that we throw at it. If we were able to gather like 10 petabytes of screen share data and like train models that what people do on the computer, what would that actually do? People look at other people's jobs and assume they would be easy to automate. The famous example of Jeffrey Hinton, he thought radiology was going to be automated in the next few years. And it's all based on like sophisticated pattern matching. And so, you look, that's what convolutional neural networks do. Ad technology has been around for 10 years and like it doesn't seem to be happening.
If you could automate away the tedious, repetitive, sort of easy parts of someone's job, then they would be much more productive, and you'd also be lowering the cost of their labor. Like you'd be making them more available.
We need one of those mad scientists who's been recording their corporate meetings forever. It was a little bit about training a model, and it's like, okay, I'm going to do this on myself so that I can go to everyone else saying, hey, but I'm now cut down my workload by 30%. Welcome to the SVIC podcast, where we deliver tech insights without the hype. Join my co-host, Joe Ternasky, and me, Jordan Thibodeau, as we break down the latest in tech, cut through the hype, and host top industry guests for exclusive insights. Welcome to the SVIC podcast. Today, Jack Morris is joining us. As a PhD student in computer science at Cornell, and he also worked at Google doing research. He is part of their AI Residency program, and then now he's over at Meta. And so he has a fantastic Twitter that y'all should follow. I'm going to present it on the screen real quick, if I can get my computer to work. Okay, it is called Jack Morris. So y'all should check it out, JXMNOP. And then he has a fantastic Substack, which you all should check out. If you go to Substack and type in Jack Morris, you should find him there. So, Jack, thank you for joining us. We appreciate it.
Hey, thanks for having me.
Yeah, anytime. So many different directions to start with, like just the absolute craziness that's going on in AI. And so, gosh, like there's so many different areas to go into. I think recently you wrote a newsletter about just there's been a plethora of AI research coming out, but maybe some of it's not necessarily moving the needle and people are taking low risk and not going for high risk. Maybe you can kind of talk about that.
Yeah, sure. Where should we begin? I think that writing came from this question of like, are we making more progress than we used to be making? And a lot of people have been thinking about that. If you look at where things were 100 years ago, like at least in the United States, we went from mostly an agricultural society and then went through the Industrial Revolution, and 100 years ago everything started changing, and like things from some perspective started improving really rapidly. Like we built all the roads and we went from riding horses to riding in cars, and we invented airplanes and electricity and phones, and all of this happened in like 100 years. We built the great cities of America and started crossing the ocean much more quickly, and like it seemed like the world was changing so fast from like maybe even like 2 generations before mine. And then now it feels like things maybe aren't changing that fast, or at least if you look around, things kind of look the same as they were like 10 or 20 years ago. And it seems unlikely that we're developing more slowly than we used to be. Maybe more like things are happening more in the digital space than in like, I don't know, physical space or something like that. But I was hyper focused on this question of like, oh, is AI as a field moving more quickly or less quickly or like at the same pace than it was before? Because if you look at the progress, if you measure progress in terms of like the amount of research that gets published, whether that's in terms of like, I don't know, the number of people actually doing the research, the number of people going to conferences, or the number of papers that get posted online, or the number of papers that actually get published. Like however you look at this, it's sort of like growing way, way, way more quickly than it used to be. Like it actually looks almost like an exponential curve. I think I was like kind of trying to plot that in the newsletter, and it's like it's definitely increasing every year. I'm not sure if it's actually doubling, but I think it's doubling every few years. Yeah, so that's the number of submissions to NeurIPS, which is the biggest AI conference, just as one metric. So I guess there's kind of like a blip for COVID, but it's something like an exponential curve. And then I guess the question I'm posing is like, why doesn't it feel like we're discovering things at that rate. And I think that's a little hand wavy. But if you ask anyone that's kind of like doing the research, I don't think anyone thinks the amount we're like really learning about the world is in the shape of this. It would be plotted in the shape of this curve, if that makes sense. So I'm sort of trying to square these two things. Like if we're learning about, let's say it's the same amount as we were 5 years ago, then why is the number of papers on this exponential trajectory?
Yeah, these feel like, I would call them activity metrics. Like you said, number of people attending conferences, number of papers. It's sort of like what's happening, what activity can you measure? And then you're, I think, contrasting that with sort of the impact of the research, like how qualitatively advanced are we based on this activity?
Right.
And you're basically saying we got a ton of activity and it's increasing at an impressive rate, maybe exponential, who knows? But the actual impact of all that activity feels much less, maybe linear and at a slow rate. Is that accurate?
Yeah, I think that's right. And so if you try to square these two things, like the amount of activity we're doing versus the impact per activity or something, you get something that tells you that like the amount of impact per paper is probably going down. And so I was trying to understand what that means in terms of like starting a new research project, like should you even work in AI? And if you do, how do you avoid this problem? And so this picture is something like talking about, oh, a few years ago, if the amount of space that all the research occupies has a certain volume, then maybe there was like more open space, and then certain research kind of like pushes forward into that boundary and expands the total amount of space there is for all the research to occupy. And then other research just sort of like takes up space without
Mm,
expanding the total amount of space available to everyone. And that's why it feels crowded in some
yeah.
sense. And so I think my overall point is that like really good ideas, like it maybe be helpful if I gave some concrete examples here, like transformers, like the architecture that underlies kind of all of modern AI, like open just a huge amount of volume for people to do research in. You can ask yourself, how do you make this faster? Or how do you make them a little bit better? Or how do you run them on certain hardware? Or what are the advantages and disadvantages? There's like so many questions to ask. Or another good example is like O1, the OpenAI model, the test time compute kind of like research area. Even though, I mean, some people say, OpenAI, they're not really open, even though that's like the word in the name. But actually, I think they gave us like quite a bit of information, maybe more than you would expect. Like they released like a blog post kind of explaining this is like a fine-tuned version of our original autoregressive causal transformers, and it just sort of uses more tokens. And here's some like rough specs of like how it works. Like they gave us some information. They gave us enough in that it expanded into this vast research area. I was actually just looking up this paper this morning and observing that. So, like this one paper that was published in January, so it's 5 months old, already has 300 citations, which means like other people have published their papers referencing this paper from January, which is like, I've never seen that before. That's sort of crazy progress. And that's all to say that some ideas like Transformers and O1 maybe net positive in some sense because they like are so important that they open up more space for other people to occupy. And it's hard to know a priori that your research is going to do that, but you can definitely say after the fact that the people that are doing that are probably like contributing a lot more than people that are just sort of like answering questions that were maybe like implicitly set out by other people.
Please make sure to hit that like and subscribe button and that notification bell. And if you want to see more of our exclusive content, hit that join button. Thanks.
But you made a bunch of points there, but I mean, 300 references in a few months, that goes back to your point about the pace of the activity, right? That just says there's been thousands of new papers in ML and 300 of them reference this paper. But it doesn't actually say if this paper is high impact compared to other ones in the past. It just tells us it has a high reference count. It's got a great page rank. or citation rank.
Mhm.
And then also your diagram showing the sort of shape of overall the research space and how there's many more research groups sort of populating it. I don't know if that was your diagram or if you intended this, but it looked like the new research groups were all going into the white space. Like they weren't clustered based on where people saw the biggest problem. They were spread out in a way that no one was overlapping their work. Is that your intention?
I guess that just happened by the nature of like the newer space is just sort of like all occupied in all dimensions. I see your point. Like maybe you're saying like the people that are more established are more likely to like find new areas or something.
Yeah. I mean,
Whereas
it's natural to look for white space and not try to duplicate someone else's effort. But if I go to like I think it was Hamming's essay about how to do your research, his thing was like pick the biggest problem in your field and go after it 100%. I think that's a good summary.
yeah, that's a great summary. Yeah, he says something like he asked people what's the biggest problem in their field, and then they would explain it, and then he would say, "Well, why aren't you working on that?" or something.
Yeah.
And
Why
I
not?
guess yeah, I mean, I love the mentality. I think maybe we could play devil's advocate for a second and ask like, why is that hard? Like maybe that's the aspiration of all researchers, but like in AI, that's hard for various reasons. Like a big one being compute, like
Mm,
maybe you just don't. So some people think that like problems are only meaningful if you demonstrate them at sufficient scale, and that takes resources. And like now the scale, maybe it's that gap is shrinking, but still like that's not available to everyone. And so like if you're some random person who doesn't is just sort of like doing research on their own without any institutional backing, and you don't have access to like the big computers and fancy GPUs, and you come up with a new idea to make like a better chat GPT, it's really hard to demonstrate that in a way that would be meaningful to the people that matter.
right. So you just don't have the budget.
Yeah, maybe you don't have the budget, or even you don't have like some of the like what do they call it? Like tacit knowledge, like things that if
Mm,
you work at Google, the kind of things that people say to each other without even meaning to, but actually are really important to know.
right. And since we're going after the devil's advocate position, maybe if you pick the biggest problem, you're going to be in competition with the best people. So that's a high risk, high reward sort of move.
That's definitely true, and that's something that you'll hear from people. Like if you go to NeurIPS and then you're talking to your friends about like what are they working on, and then you say, "Oh, I'm working on reasoning models like O1,"
Hmm.
and people would say, "Oh, that's like really crowded right now." And I think the subtext is like that it's very competitive, and that maybe like if you have an idea like what if it worked like this, or I don't know, what if we tested the model in some different way and that would exhibit some interesting behavior, like there are more people looking at that space from that angle, which means that like the chances that someone else also does that are higher, which means I think like if you're working on anything and you didn't exist and in 6 months someone would have done the exact same thing that you were to do, then maybe it's not as meaningful in some sense. Then like
Right.
you have to
Right.
do it, because if you don't do it, no
And
one
you got to
else
have
will.
a ton of confidence in yourself and your team to go after a problem that you think the very top people in the field are also focused on.
Yeah, right. And you either have to believe that like you're better than them, or that you have some insight that other people don't, or you have some
Yeah.
other kind of advantage that maybe they
Yeah.
lack. And
Yeah.
I
You got
think
to
for
have
a
an
lot of
angle.
scientists, that's like background from like the pre-AI area that they're able to like apply over and over again to get like new perspectives on problems that didn't exist.
Is
So the
this the
result is everyone's spread out. In the diagram, the field's expanded and the coverage is total and nobody's overlapping. I mean, it's an ideal description, but it means that you expect to see a lot of papers, a lot of work, but maybe most of it is sort of not important.
Yeah, I think that's maybe the implication, is that like a lot of there's some stuff that maybe no one even needed to do because it's like so obvious. And also that the rate of like when O1 happens, or something that I was saying sort of like expands the boundary of all the things that are considered research, like the rate at which that empty space is filled is just like so high now. Like this paper gets 300 citations in 4 months or 5 months. That's because so many people are moving so quickly to like execute these projects and like sort of contribute to the body of knowledge. But I'm saying like I don't know how much we're actually benefiting from that, like as a society.
Mm-hmm. Mm-hmm.
So you must, I mean, you have tons of research papers coming at you. How do you triage? Like, this is actually novel, and this is just another Me Too benchmark hill climbing. Great.
I don't know if I'm like super qualified to answer this. I definitely read a lot. So in some sense, maybe like I should have better kind of like defenses, and I just sort of like believe what people claim and then start reading. I can tell you like the things that work for me. Like I think talking to people is a big one. Like just being like in my PhD in Cornell or in Meta at Fair, like both those places, I think you just hear about stuff like people come get presentations, or you're just talking to someone, they tell you, oh, you should look at this. And I think that's probably like the number one good way I learn about things that are meaningful to me is just through word of mouth. And then the second thing I think is actually through like the citation graphs of papers. Like if there's something that you think is really good, then they have their own like people that they reference. It kind of comes back to the page rank idea you mentioned, where it's like if so you think someone's idea is really good, then you kind of like trust them, and then you also sort of like trust the people that they trust. And so I think like a lot of it comes down from like if I think a paper is really good, I'll spend a lot of time on it, which includes like at least kind of clicking through the main things that they reference in their like related work section.
So following up on the references that look interesting, getting a sense of the reputation of the people involved, and also relying on your social interactions with other people to see what papers they found exciting recently.
Yeah, I mean, I'd be curious what you all think works for you, but I I would add that like I think the overall effort and importance of like the individual unit of a research paper has decreased, at least in the average case. And so like I don't know, this kind of happened in tandem with the fact that like I've been doing AI research for 7 years, maybe 8 years, just not that long. And like so
Before it was cool.
I don't know. Like, I think there's people that have been doing it for like way longer than that. But like, I guess when I was like a little bit more junior, I would read things more deeply. But also at the
Mm.
same time, I feel like they really have gotten less important. Like, so it's hard to like disentangle those two things. But both because I've like read more papers, which has made me need to read each one less. But also at the same time, like things are getting less important, I think, paper by paper. So for those two reasons, like when new research comes out, I tend to like often just read the introduction and kind of like the claims they're making. And then probably 4 times out of 5, that's it now. And then like 1 out of every 5 times, I'll actually kind of try to read the whole paper.
Yeah, that sounds like the Ternasky style. Joe taught me read abstract, then go to the last page, see if there's anything like in the conclusion section, see if there's anything novel or where the results, and kind of go from there. Because for me, I'm some political science wannabe AI person here, but I remember when ChatGPT came out, it felt like 2023. I was reading all the research papers, like, oh, wow, this is amazing. This agent framework here, like, look at this, what they're doing here, blah. Then 2024 was like, yeah, seen it. You've improved in this benchmark or whatnot. And then it just felt like you mentioned, it felt like there's like a law of diminishing returns on the flood of papers that were coming in. But that's who am I anyways? Joe, I'd love to hear what your thoughts are.
No, I think that that's reasonable. And maybe there's a reflexive kind of characteristic to this. On the one hand, because you read a bunch of papers, and in your case, you're doing the research actively, you're getting better at interpreting the claims of the paper, so you can absorb incremental research much more quickly, and you can also sort of judge the impact of what you're reading and say, is this introduction telling me anything that I don't know already? Do I need to bother to dive into this paper and really understand all these detailed methods? Or have I already got a good handle on this and I would be better served by moving on to the next paper, which might be a higher impact, right? Because I'm guessing from your perspective, these things are coming at you fast. Going to your earlier points, the rate at which they're coming at you keeps increasing. And so therefore you have to get even more skeptical about how much time you're going to spend on a given paper on average, right? And the only real tool you have to do that is the social interaction you described, recommendations from peers, how you think of those peers that are making the recommendations. That's a social network kind of value. And then if you do start reading the paper, does it grab your attention, and are you excited or confused or something that warrants reading the rest?
Yeah, maybe it's worth taking a second and talking about like what a research paper is actually supposed to convey. Not
Yeah,
that
go
I'm
for it.
not that I'm like know the answer, but it seems like in practice, like what the goal is for people to get their paper reviewed and published by other people that are respected like in their area. And so that means that most research papers, at least in their original form, are written to convey information to other people that are experts in their sub area. So like I saw, someone discussing recently online about how like ChatGPT is so much better at explaining papers than the papers themselves. Therefore, like the paper is bad at explaining stuff. But it's like missing the point that like research papers are not written to be necessarily good at explaining their own content. They're more like trying to sell an idea to other people that work in the same area, which is kind of like a niche purpose. And maybe that's a reason to argue that you shouldn't actually read that many. And that's where like I think a lot of the arguments people have about research come from is like you at least in our area, things are very experimental. So you kind of like do something, you interact with the world in some way, and then you explain that, and then on top of that, you get to make these claims about like what that means. And that's the part that becomes very controversial. Like I'm gonna pick an example and I'm gonna try to avoid doing this in a critical way because I really don't have that many like thoughts either way. But there's this paper that came out recently that's called like I think it's called The Illusion of Reasoning from Apple.
Yeah.
So it's about language models and I don't even know the whole setup. I just know like what someone showed me, but they tackled this old computer science problem called towers of Hanoi.
Mm-hmm.
You kind of like
Mm-hmm.
stack, you have like three towers and they have blocks of different size and you're moving blocks back and forth. And I know it's popular. I think people like it maybe in the academic community because they're like, oh, towers of Hanoi, like computer science. We love towers of Hanoi. But really, it's at least if I remember correctly, I think it's for demonstrating recursion because it has like a
Yes.
very short recursive solution where it's something
Yes.
like I don't know, you flip the blocks and
I mean, it's a classic for teaching computer science undergraduates how to write a recursive solution.
For noobs,
right.
recursive solution.
Yeah, but they did something in this paper that required like I think you have to write out the full solution. So actually,
Mm-hmm.
the language model doesn't get to do the recursion. It has to like
Right.
procedurally explain the entire thing, which is
Mm-hmm.
hard. But
Mm-hmm.
that's not my point. I guess my point is like they run experiments on towers of Hanoi with like different sized towers. And then like they write this paper and the paper says like there, towers of Hanoi, da da da, this happened. And then they say, oh, therefore like language models cannot reason.
Mm-hmm.
And that's just like a pretty crazy jump in terms of the argument. And so I think some people were upset with that. Like what they're really showing is like, oh, language models under these certain models under certain conditions cannot execute towers of Hanoi with certain, I guess, like sequence length. And then like I mean, we have to build narratives around these kinds of things to like understand the world, but maybe like going from that piece of evidence to making like a very general claim is
Mm.
bound to have some controversy behind it at least.
Yeah, they definitely opened a can of worms on that one. And I think some of the responses were fairly well, some people were just outraged, but some of the responses were pretty concise and to the point. Like people took that exact same problem with a depth of 10 disks, right as they described it in the paper, and then passed it to a more recent model and said, solve this problem, and the model succeeded.
Really?
Yeah, and so it's like, okay, how hard did you try? Like, how many different prompts did you attempt? How much effort did you really put into this before you publish this? Is that just, it kind of looks a little bit iffy. But I take your point that, going back to the beginning of this part of the conversation, The point of the research is to ask interesting questions, I think, and then to answer them and expose how you explored them so that someone who comes behind you has a chance to pick it up and go even further. But I would say of this paper specifically, it's almost like it's not even asking an interesting question. Like it's not even framing it in an exciting way.
Yeah, yeah. And maybe there's a misconception that like something has to become this really like powerful general statement for it to be important or something. But
Yeah.
there are definitely cases of like really small problems or systems that I think have made really good, useful empirical claims and like, had impact. One that comes to mind is like this grokking thing. Have you all heard of that?
Yeah, yeah. But go ahead and give us your example because I think this is interesting.
Okay, so grokking is this phenomenon where if you train for a really, really long time, or in some cases the model will go sort of switch from like memorizing a small training data set to like learning a general pattern. And I think
Mm-hmm.
that
Mm-hmm.
the reason it happens has something to do with like gradient descent, and gradient descent in batches introduces noise, which somehow like regularizes to a simple solution, which is a crazy phenomenon that occurs. But they test on this problem of like modular arithmetic. So it's like really simple math problems, and there are only
Mm-hmm.
like, I don't know, I think in the base they use, there's like 100 of them or something. So it's like a tiny training data set and a really small model. And it's a very contrived scenario,
Mm-hmm.
but also it's like important. And I think like has gotten a lot of attention and study because of that.
Yeah, this is almost like the approach in physics where you try to reduce the problem down to something really simple that can be completely explored and then explained. And then if it works, if you understand the principles at that level, then you hope you can scale it up to the larger, more complex examples. So,
Mm.
to me, seeing a paper like that and realizing, wow, they've really cornered this model. It's such a small model. And then they've almost forced it to generalize in order to be successful, to hit that sort of threshold where it starts doing this grokking. And then your immediate, at least my immediate question was, holy shit, will that work in bigger, more complex cases?
Hmm.
Is that what's happening when a large language model begins to really feel like it understands what you're discussing rather than just regurgitating training samples?
Yeah, yeah. I definitely think it's a good sign when you hear about someone's ideas, then they immediately make you ask new questions and
Mm-hmm.
come up with new ideas, and maybe that ties back to the kind of like territory expanding type of research that we're looking for.
That's a great description of it. Territory expanding, exactly. I mean, just that result, even though part of your mind is thinking, well, this is a really small environment, the sort of physics style of problem, ideal problem. But the other half of you is like, oh my God, all these new questions and new areas open up if this is true.
Yeah, maybe we could go as far as to say is like more people should be trying to do research like that. There's one other example that comes to mind when you make the physics analogy, which is like a little bit older, but and I think people aren't working on it as much anymore, but there was a bunch of research on like this idea of pruning where you could kind of delete edges from a neural network or something and retain performance. And there's an original paper about it called like the lottery ticket hypothesis from
Mm-hmm.
Jonathan Frankel.
Yeah.
And that it's also a very simple setting where they train neural networks of, by today's standards, very small size on maybe just MNIST or some small like data sets that are probably not super realistic, but it's like so thorough, and they just explore it from so many different angles and ask so many different small sub questions, and every claim they make is backed by evidence on many different dimensions. And I think that type of research is really hard, but when people do it, it definitely gets noticed.
How do you, so that's another great example. I'm really curious. I've never seen anyone define this area or this idea of an important question that opens up new areas of inquiry. to me, it's a kind of a feeling that I get when I'm reading something and I'm getting excited and thinking, holy shit, if this is true. And then I'm really curious to read more of the paper and know why they think it's true. Even if it's otherwise, like you described in the lottery ticket hypothesis, it might be really tedious to look through all the experiments, but the stakes are very high at that point. From a sort of intellectual perspective, it's like, hey, if this is really true, it's really important, and it means a whole bunch of possibilities are in front of us. How do you characterize that quality in a paper, and how do you rate it? How do we quantify it?
Yeah, that's a really hard question. It reminds me of, being in grad school, there's a lot of talks, and you kind of know if a talk went well if there's like, I don't know, at least
Mm.
3 questions
Yep.
afterward. And if someone gives a whole talk, they're talking for an hour and then they finish and no one asks any questions, it probably just means like either no one's interested or at some point everyone got like exhausted trying to pay attention and everyone's like,
They just want to break for lunch.
yeah,
Yeah.
exactly. So like I don't know exactly what the research analog is where you produce some piece of writing and then by reading it you create in other people's minds like new ideas like that, that's kind of like really what you're trying to communicate, but I don't know how to like recognize.
Right. I good point regarding like you do a presentation and people are like pushing back at you or asking you questions. Sometimes you take it as my presentation didn't go well. It's like, no, actually you're engaging people's minds. They're willing to actually talk and ask you questions to probe you. Another thing I see in some research papers, they always say, and like at the end, in further areas like you go into, and some maybe have like a few, one or two areas. And other research papers, I'll see like 4 or 5 or 6 or 7. I'm like, oh wow, they're saying there's all these areas they want to go into, but didn't have time. Does that also serve as a way of kind of reaching out like indirectly for getting other researchers involved in your research, like saying like you put your paper out there to see if you can recruit other folks to join you?
Oh, are you saying like for a future work
Yeah.
Yes.
section
Yep.
kind of thing? You say
Yeah.
like, oh, this is what we'd love to do next or something? Yeah, that gets into this whole thing of like, how do you get people interested in an idea? But then also sometimes maybe people actually do have like things that they need help with. I've had this happen to me a couple times where like I finished a research project and then for some reason or another there was a part of it that we didn't get to or that we thought was so obvious that like someone might do it. But like it doesn't really always happen. Like I feel like people really or a similar thing is like I've had these new research ideas that I thought would be awesome projects and ask interesting questions and one day could make a great paper, but I didn't have the energy to do or the time or I don't know, was interested in something else or for whatever reason I sort of like wrote it all up and then basically tried to convince someone else to work on it. And that's like really hard, I've found. Just because people are so much more motivated, I think, by their own like internal quests and questions than like anything you could present them with.
Mm.
Unless there's some kind of like an extrinsic reason why it's like a good problem to work on. Like I think I think people really like working on things that they feel like they came up with themselves
Mm-hmm.
for
Mm.
the most part.
Yeah, that's true because we like to feel like we have ownership over this idea and we're
Yeah.
crafting it, not like we're just working on someone else's dream. Now, this is kind of a good segue to you've now worked at two major corporations and research labs, Google and Meta. What's it like being inside of there? Were there any misconceptions that researchers have when they go inside these large organizations?
Yeah, I guess I should preface this and say I've spent probably about I guess a year and a half total in Google and a year in Meta. So other people have been at both of them much longer. So I want to put a disclaimer out there and say
Mhm.
like, other people probably have more representative experiences. They're also really big companies. So you only ever experience one very small part of like the large corporate ocean. Misconceptions. Well, Meta, both Google, when I was at Google, it was split into Google AI and Google Brain and DeepMind, and all of those were separate, or at least DeepMind was separate. And then they've recently merged into GDM. But while I was there, I was in Brain, and it was like this separate institution. And at that point, it was like, I mean, this is basically during the pandemic. It was so independent and like everything was great. Like you could basically do whatever you wanted to do research on, at least as long as the person sort of like managing you was on board, you could do whatever. The compute is amazing. Like it's a great place to work. Meta is now split into Gen AI and FAIR, which have like
Hmm.
very different purposes. They both do AI research, and then now maybe there's like some new third thing popping up. But actually, only people have sent me news articles about that. Like, I know nothing about that. I think like this is probably the model that most large AI labs will follow eventually, is just having this classic distinction of like production and kind of like basic research. And I think Gen AI is like building things that are useful for Meta's billions of users and like just other people. And then FAIR is more like about asking basic scientific questions. I think now maybe more people are interested in like stuff that's closer to production than they used to be. But by and large, you can like it really is amazing that any corporations are funding this for whatever reason. Like that you can just there's people working on crazy stuff. I know in Google they have like a pretty good sized team working on smell, like the science of
Hmm.
the nose. I don't know if you all know about that.
Mm-mm.
I don't really either. I know they're trying to build some digital nose with like sensors, but I don't know
Interesting.
how it works or anything. And then in FAIR, they have a good amount of chemists as well.
Oh, really?
Hmm.
Go into that?
I can't.
Okay.
I'm just bringing it up as a reason, as a point that they're just sort of like. It seems good that they're funding science in general, and I think it's more like it's good for the brand and nice way to get smart people interested in the company, but it's not. I don't think that there's any intention to ever like really merge that into Instagram or anything.
Yeah. Yeah, I remember when DeepMind, when ChatGPT came out and they did the restructure of DeepMind later on, there was some grumbling in DeepMind researchers saying, hey, they want my work to go into production now. Like, what's going on here? And so it's interesting to see that shift. But I also want to talk about one of your tweets here. You mentioned people don't realize, but LLMs saved AI. If we didn't stumble into general intelligence, most people would still be working on vision, which was most useful for human surveillance and ad targeting, inherently evil technologies. And when I saw that, it was interesting because I remember when Joe's going to correct me on this. Francois Cholet, the
That's
French
why, yeah,
research. Yes, yes,
you got it.
brilliant guy, gigantic IQ, super smart than me. I remember he was doing an interview on Rakesh Patel about the ARC Prize, and he made some comments saying, right now everyone's focusing attention on LLMs, and that's taking attention from other places in AI research. And I was thinking to myself, like, wait, hold on, this is the first time with LLMs we have a commercially viable algorithm that you can build a business around that then normies who never have controlled AI before can actually instruct AI to do things. And if anything, this will be an opportunity for these businesses that are focused on these technology to then fund more research in AI, not necessarily just in LLMs, compared to what we had a couple of years ago, where it was kind of just like a side play thing for large organizations, and we would deploy it on the algo, but you had no way to really control it. So I love to hear more of your thoughts on that.
Yeah, I guess I can respond specifically to the question of like whether LLMs are taking attention away from
Mm-hmm.
other things. So there are definitely a ton of people working on LLMs, and maybe they could be working more on like bigger, more basic scientific questions, and that would be better. I think, at least personally, I believe at this point that language models are basically synonymous with AI, in like the
Mm.
fact that like the future systems, that the things we all think about, like in the year 2050, will we have like sentient robots walking around our house, or will there be some like AGI takeover in the next 5-10 years? Like when you say AGI, it really is like language models, and then anything else that is not based around language will get integrated into that system by means of coupling it with language. So like vision is a great example. I mean, what is it? There's like sort of audio, kind of like planning, RL, robotics work,
Hmm.
vision. I think all these domains will just everything, a video, it'll all sort of like merge. And I think that the language models are like the things that work now for whatever reason, but eventually we'll have some kind of larger, more general intelligent systems. But I doubt we'll like ever move to any other thing. It'll be more like we start with the language models and they'll kind of like graduate to more sophisticated general things. So I guess that's all to say that I think I don't think there's anything better to work on, honestly, than language models. And if you're working on something else, it'll probably eventually get merged with language models.
Mm.
But it's definitely not a waste.
Yeah, I think for LLMs is probably the best system that just understands humans and can take all of our crazy thoughts or unstructured information and kind of put some logic towards it or distribute it to other systems that can maybe give you a correct answer. What? Oh, go ahead, Joe.
I was going to say this one's also really tricky because when you say large language models to the public, you're framing a whole bunch of things in their mind together, right? They're thinking Chat GPT, they're thinking about a language model, and they're thinking about the transformer and all the approaches that go with those three things. But then if you look at what's happening in, I don't know, vision research, object detection and so on, a lot of it is vision transformers. So you're leveraging the same transformer model, but it's not technically a language model. It is still tokenizing parts of the image, and so there's a lot of components in common. And then to your point, Jack, every time I see one used, it's always bonded to a large language model in order to get any kind of queries into it, right? Or any kind of responses that are in a format we can make sense of. So it seems like the language model always gets combined, and it seems like, to your earlier point, a massive amount of the research effort and product effort is in some kind of transformer model, even if it's not a large language model.
Yeah, I agree. So transformers are good for a lot of things besides text data. And there are other kind of parts of the stack that are also transferable, like building better hardware or better kernels for the hardware or better optimization algorithms or even just kind of better software, like better PyTorch or integrations. All of that kind of helps everyone. And I think actually a lot of the people doing that, the kernels people are all kind of making transformers faster right now for LLMs, but I'm sure that uh, bleeds down into other areas as well.
Yeah, if you're doing research on something else and you can manage to leverage PyTorch or the various frameworks that do GPU kernel fusion to get better performance, there's just a ton of stuff in that stack that really was mostly developed. I can't say this 100%, but it's mostly been invested in because of large language models.
Mm.
But it could benefit people doing all kinds of different research.
Yeah, and maybe that'll be in 10 years and there'll be some other application of GPUs that we can't imagine right now, but it'll only be enabled by the fact that we made them so fast to use them for AI.
Right. Just like these GPUs became available enough and cheap enough because so many people were excited about playing third person or first person shooter video games. And then they became a way to run neural networks in a much more optimized way, right?
You
It
forgot about
wasn't like,
crypto.
what's that?
Well, you forgot about crypto mining.
That's right. Crypto mining too. But my point is going to what you said about you developed this low level GPU architecture and kernel fusion problems and CUDA and all this other stuff in the stack for one reason. And then it turned out that it was really useful for something like AlexNet, right? Because someone really took advantage of it. Now we just think of GPUs as being the foundation for large language models. Almost like we're kind of mentally revising the history. Like the reason why we built GPUs was to run language models faster.
Right, but no one could have seen that coming. I feel this is the dream of every professional mathematician, is that their area is actually useful. It won't become useful for 200 years, but then those people will all be reading through all of their work to understand it better.
Yeah, it's always amazing. Like the gentleman who created the perceptron that eventually did the multi-layer perceptron. He was just 70 years ahead of his time.
Yeah, that guy was actually at Cornell, I think, Rosenblatt.
Mm-hmm. Mm-hmm.
Amazing. Let's go to your next one, because right now everyone's talking about AI and job loss and things like that. And I think you had a really good take on this. Copilot for everything, training your AI replacement one keystroke at a time. Our employees have all the data they need to train AI models to replace us. How long will it be until it actually happens? Later on, you go into it and you say, and everyone should read this. It's a really good newsletter. The reality is that every remote worker's job tends to be repetitive sometimes, and your value comes from how you handle the least repetitive things you do, reacting to novel situations, adapting to change. New tools reduce the amount of repetition in your work. Our day-to-day jobs become less predictable as our most mundane and monotonous tasks are modeled away. I thought that was the most like succinct way of putting it, the way I feel about all this, because there's been a meme going on from everyone in Anthropic saying we have enough data to get rid of everyone's jobs in 4 years and you're all cooked. And I was like, wait, hold on. I've been in M&A. I don't know if there's like a reward signal you can get for how to properly merge teams together or dealing with internal corporate politics and whatnot. Now, if you look at job tasks, like, yeah, like sending offer letters out, please automate that crap. Dealing with the I-9 stuff, automate that stuff. So I thought that newsletter was really solid. Any thoughts on like what inspired you to write that one, and any other reactions you've gotten from it since you released it?
Yeah, a couple people reached out to me that they made them think about their own jobs more. I guess the reason that I decided to write that was just the thought experiment about like what data do we have? Like AI is just getting really good at learning from the data that we throw at it, and every once in a while we kind of come up with a new type of data to throw at it, and then we get better AI. Something that seems under leveraged is like recordings of screens, I think. And I don't know why. Maybe privacy is a huge issue. Like, how do you collect a data set like that without identifying people? And also, like, most of the data that would be useful for that is probably proprietary to different corporations. So it's hard to like. I guess I'm saying that because a lot of the AI data sets tend to be like these big public kind of enterprises. Seems like it would be hard to do with screen sharing. But if we like put that aside for a second and consider what the world would look like if we were able to gather like 10 petabytes of screen share data or whatever and like train models that just sort of like model what people do on the computer, like what would that actually do? Or like how would you even use that? It's an interesting thought experiment. I think that there's a common fallacy that people kind of like look at other people's jobs and like assume they would be easy to automate. Like I know the famous example of Jeffrey Hinton, who's like probably the most influential researcher ever in AI, and he's said a bunch of times for seemingly no reason to the press that like he thought radiology was going to be automated like in the next few years. Yeah, right, right. There's this book called The Digital Doctor, I think, that talks a lot about that and how like because radiologists kind of like look at patterns, like they look at, microscopic what do they call them? Like those panels with the zoomed in cells all day and they diagnose cancer and they diagnose other forms of disease and it's all based on like this sophisticated pattern matching and so you can look at that and say oh that's what convolutional neural networks do so you just gather a large supervised data set and you can solve that problem but like that technology has been around for 10 years and like it doesn't seem to be happening. I think somewhere recently I read that there's actually more radiologists that were trained in the last year than ever before. So it
Yes,
also
it's in
seems
that
like
story, New York Times. You're correct. And the lady there is a radiologist. He's like, this AI tech's fantastic. It handles all those different things. It gives me prediction on measuring like certain things that I think could possibly be cancer instead of me manually doing it and saves me 30, 40 seconds per 30 minutes per like x-ray review or something. And it gives her more time to spend talking to doctors, talking to patients, and doing all the rigmarole of their job. Yeah.
yeah, that's really interesting. Like I'm not an economist, so like it doesn't actually make perfect sense to me why someone can become that much more efficient at their job and we would just train more of them, but I guess that seems to be what's happening.
Well, the theory is that if you could automate, to your earlier point, if you could automate away the tedious, repetitive, sort of easy parts of someone's job, then they would be much more productive. And you'd also be, as an economist, you'd be lowering the cost of their labor. Like you'd be making them more available.
Right. And Jack, thank God when you're in these corporations, you're nestled away from all the meeting theater, what me and Joe went through. We spend, there's days where we spend 6-7 hours in meetings and you want to like just blow your head off. And no, people don't blow your head off. Suicide prevention hotlines here. Don't do it. So, but I remember when ChatGPT came out, I messaged Slack product managers. I was like, hey, there's like this Thibodeau's hierarchy of corporate communication. And the bottom of it is just basically, are you free for a meeting at this time? Are you in for lunch? Blah, blah. And then you have the medium level, which is what's going on with project X, Y, and Z, blah, 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 blah.
Status
And then
update.
top is like, we need you to make a decision on something. And
Mm-hmm.
so when I read your newsletter, I was like, this guy gets it. But you put it in a better format than I could put it to the product managers. So product managers, we're at Slack. We have all my DMs. Why can't you make an LLM bot that kind of intercepts the bottom level of like, are you free for meeting at this time? And they're like, oh, this is Becky. I don't want to talk to her. Okay, no, sorry, Jordan's not available. And then for the medium tier ones, you have the LLM trained on a certain Slack channel for a certain project, and then the bot can intercept on based on my behalf for like a whitelist or something. And I was thinking about that, and the way you phrased it, I was thinking of like, let's embrace the technology. But then there's other people who look at that saying, oh, wait a minute, I'm getting rid of my job. Like I'm not gonna have an opportunity to do stuff. And I think you have what's going on is this clutching of pearls where people think, oh, if I train a model on me, then the next step is they get rid of me instantaneously. But I think there's this 80-20 rule of there's only like a few decisions you make per quarter that add all the value for your career, but you can only specifically do it because you have that world of knowledge and experience that you might not be able to get in a certain model. But I'll stop talking now. Jack, any thoughts?
Yeah, I mean, I think it's hard to predict the future, but definitely those kinds of administrative tasks that happen many times seem like the kinds of things that could be easily solvable by this technology because you could collect a data set of them and build some kind of prediction system that can get to 99.9% accuracy on cases it's never seen before. And then you could actually use it to schedule your meetings. I'm not sure why it's not happening yet. I guess just like reliability, but it seems like we should be very close.
Yeah, we need like one of those mad scientists. Not to say this guy's a mad scientist, but I guess the medical research on the idea of ulcers back in the day was like, no, it's something that has nothing to do with bacteria. And then one researcher was like, no, it's to do with bacteria. And so he ended up giving himself an ulcer to
Mm-hmm.
prove, and then give himself
Yeah,
give
Yeah.
himself
the
what's it called?
Hardcore.
penicillin.
Yeah, and then he proved it. And so it's like we need one of those mad scientists who's been recording their corporate meetings forever, knows a little bit about training a model, and is like, okay, I'm going to do this on myself so that I can go to everyone else saying, hey, you're against me doing this, but I'm now cut down my workload by 30% because I did this to myself.
It's the
Yeah,
patient zero of meeting scheduling.
exactly.
And
Yeah.
once he shows that it's doable, then you think everyone else will adopt it.
Yes, that's my hypothesis. We have 4 minutes left. Jack, was there something that you want to talk about that you think we should have covered, or what's on top of your mind right now in the AI space?
Especially research ideas that you're thinking about.
Okay, I guess top of my mind very recently is two things. I guess one is building new systems for memory,
Mm-hmm.
and the other is reasoning. One, like, I don't think I understand how it works still. I think like pre-training makes perfect sense. Like you kind of just like feed the
Next
model as
token
much
prediction.
data as possible, and then over time it gets better and better at modeling the data, and the returns are diminishing, but they kind of like continue forever. And that's like so easy to understand compared to like whatever is happening with the reasoning tokens and like rewards and reinforcement learning, and just it all got so messy so quickly that I feel like I'm still like I can kind of explain it or like I could kind of write out the math, but like actually understanding what's happening like on the
Mm-hmm.
same level of intuition has been really challenging for me, I think.
Mm-hmm. Mm-hmm. So memory, and on the memory side, are you thinking like hippocampal memory model or something
I don't
you don't
know. I
know?
mean, let's look at it from like the product perspective. Like, ChatGPT, they launched this memory feature where now the model can look back and read through the conversations it's had with you. That's like the first of very many, I'm sure, instances of this that we'll see in our lifetimes, like through all these different AI systems that'll try to like remember and grow from interactions that you have with it. And I guess like I have no idea how they built this, but what I would guess they do is do search over all of the conversations you've had and just plug them into the context window. And that's like very hacky, I think. Like it's not natural. You know, you would want like a system that, I don't know, continually like looks back and actually tries to like update its weights, or just something that's I think there's many ways they could make it like more sophisticated. So I've been trying to learn about like some approaches that people have written papers about and think about.
There was an interesting paper out of Google about using almost a state space kind of model as a way to extend the context window to be really huge. It's how Gemini was able to handle like 2 million tokens in the context window. They basically accumulate this state on all of the data that came into the prompt, the whole context, but then only the last part of the context window is actual context as far as the language model is concerned. That state space thing is just giving like a much condensed, almost an embedding that it hands to the language model. So it's like, here's your huge context. It's just been summarized into this set of embedding vectors. And then here's the context for the part of the conversation that's more recent.
Right, right. And then you can condense like arbitrary length things, which is like
Right.
a really nice property.
So that's a kind of memory, but it feels like the context window just got much longer.
Yeah, yeah, definitely. That I think that kind of thing is much better. So you have this kind of like external memory mechanism that's not just text, and they have some kind of like update rule for how to like store new things into it.
Right? How
Like
to
that
store
seems like
things
the right thing.
and do things age out.
Right, right. Yeah, that's really it's just a really hard problem. So I've been kind of trying to orient myself, like look things up and just hear about
Last question, Jack. This is all like you making a prediction. How long do you think it's going to be before I go to my Slack terminal and I have a process where I click everything and I press this button that says like watch what I do, and then it records, and then it just goes off somewhere to go train a model that's specifically tailored to my wacky TPS report garbage. You think
what.
we're going to see that in a decade, or what's your
It
time frame?
shouldn't be too long. I say I have to put a number on it. 3 years? I think you'll have that in 3 years.
Okay, because I'm coming back. If I'm doing corporate bitch work in 3 years, I'm going to find you in New York. And I was kidding. Jack, thank you so much. I almost hit myself with the mic. Thank you so much for coming through. All y'all should look in the description section. Follow Jack's Twitter. Follow him on Substack. You won't regret it. He's a fantastic dude. Jack, thank you for your time.
Okay. It was a lot of fun.